welcome to the last session's short talks, and I'm delighted to introduce to you Andre Farshad, and let's hear what he has to say.
Thank you very much. Well, let me introduce myself a little bit. I'm an executive IT architect. I work for IBM in large application development projects, starting from Java application development in 2000 until now large microservices projects. I work for IBM, but what I'm presenting here is my own opinion. My role in application development projects is in a way the middleman between the business and the development. So what I often hear from the business side, where I say, okay, microservice, hey, cool hype, let's do that. And you get some perceived benefits of microservices that you have to then talk to the business and even talk to developers and say, maybe that's not exactly what it really does, or there are some strings attached with it. So that we want to that we have to look at it, because this is only a short talk. This is a short version of an article I wrote. The URL will be in the end. So I'm only giving you a few dependencies and let you have a look at the article later on. So what are the promises? The promises that I hear is, okay, it's fast, it's agile, we can go to the market, we can innovate, we can do new stuff. Yeah. We can do all the tools we want. Yeah, we can use Go, we can use Erlang, we can use assembler, whatever the developer wants. Yeah, that's coming from the developer side, right? From the DevOps side or from the operation side, oh yeah, it's better resilience, it's better scalability, it's better reusability. I have a service, I can reuse that. Yeah. So all in all, the business says, oh cool, better return on investment. So, and this is something that you have to kind of put back down to earth and understand. And I will give some examples now, and then later look at these promises, how they really look in reality. So the first example, and I think we have seen that already just in the talks before, there are dependencies between services. Yeah, what my experience comes from projects that have 15, 20 teams, not 15, 20 developers, 15, 20 teams that develop different services, components, modules in a large project. And what really happens is, of course, you have those dependencies. And we've seen some example in the talk before. If you Google it, if you search for it on the internet, for the microservices Death Star, you find a lot of pictures. Yeah, you see all those dependencies. And if you have dependencies and you need some functionality that ripples through those dependencies, that concerned where you have to do changes in all those dependencies, and you have different teams for every service that's implementing the service that has to be changed in that functionality. This ripples through your project plan, or through your sprints, or through your planning in total, through your Kanban board, whatever. And what I experience is that in such cases, this becomes a waterfall. So you're not agile anymore, because then you suddenly say, oh, I need some change in my persistence service here somewhere in my order catalog. Yeah, and then before I can, when I have it there, I need something because I need this attribute somewhere in the order service. Yeah, and then this sprint, this service runs on one sprint schedule, the other service runs on another sprint schedule, and so on. Yeah, and then suddenly a functionality where you think this could be implemented in a few weeks or so takes months again. Yeah. So this is one of the challenges that you have to tackle. Another one, considering the discussion we just had, is also the data model. We have just heard the proposal and also the microservice approach that say every service has its own data model. Now we have to define what data model. I absolutely agree. Each service is responsible for its own persistence model, for its own database. There's no such thing as a big common database. And in some points you have to exchange information with other systems. And in here you have to, you should talk before you implement sometimes. We had some situations, for example, where in one service we had an address field where the street and the house number was in the same field. And the other one didn't accept that because, of course, they have it in 2 fields. But this was an international project. So, yeah, in France, the street number is in front and the street name is behind and all that stuff. And what you need to do is to at least agree when you have to exchange data. Make sure you're all using the same type. So what I meant here is I wrote common data types, and I think of this as more or less of not like entity object models or something like that, but really like complex data types or structures as you have in maybe in C, and really in this basic type of sense. And you have to, for each and every connection you have with other services, you have to really talk before you implement. Yeah. And how do you evolve that data structure? There is a common data model maybe between 2 services, but this is also versioned, of course. Yeah. In the previous talk we heard yeah, we have one common data model that leads to a deployment monolith. Of course, we have versioning in all our service APIs, and we need to take care of that as well. So this is a challenge that needs to be managed. Another challenge is the technology selection. If you're running a project with 15, 20 teams, and everyone is selecting different types of technology. One is doing JavaScript on the server, one is doing Java on the server, one is doing Go, one is doing other things, other languages. You end up with something where your maintenance cost in the end will really rise high. And the question is, you have to manage your decisions on what technology you use, because often a decision that is made by a development team is made because of perceived small advantages and not taking into account the maintenance cost in the long term. So if you look at it, of the microservices that I've seen, most of them, 90% maybe, I mean, there are 2 different kinds. There's synchronous and asynchronous streaming types. But if you look at those 2 classifications, in each of those classifications, maybe 90% of the services basically look the same. They have a REST API, they have some business functionality, they have some database. Yeah. And in a team where in a project where you have 20 teams, you don't need 3 different databases for that. Yeah. So this really needs to be managed so that in the long term you can also handle that project and the system. Because in the long term, you have to admit it, even if you're agile and DevOps and you say, yeah, I will support it in production. Once you had your 5th call in the middle of the night because some problem happened to your microservice, you say, maybe I should give it to some ops team. Yeah, or the service is more or less developed to a certain level that you only run it in maintenance mode. Yeah, you move on to another project. So who's going to support that? Yeah. And then if you have lots of different types of technology, you have a lot of cost that's attached to that. And there's also the skill requirements when it comes to something like high availability, requirements. If you, how do you set up a database? Yeah, if you have different, if every project has a different type of database, needs to do a high availability setup. Ooh. Amazon has actually created their cloud because they found out that the people, the developers, are doing much of their work running the infrastructure. Why not just go one level higher and say, okay, I have something that I can automate, that I can script, that I can manage to run that a few different setups in a way we as a project as a whole need. And then I can separate that out and can just use that as a service from a project. So all in all, and this is one of the main things. Conway's law has been mentioned. Yeah. If you look at earlier days, you had an operations team, you had a build and deployment team, you had some database admins, database developers, you have integration layers, service layer, you have front-end developers, UI developers, and they had all their different tasks, and they were all more like, I need to do my function, I need to do my what did we use in earlier times? Not Jira. Anyway, Jira tickets, implement my UI and so on, and they were not really coordinated sometimes. Now it has more or less shifted. Now it's okay. I have a microservice that's going end to end. I have a team that must or should implement from the user interface to the database, to the persistence layer, and do the operations as well in a DevOps setup. And if those people don't talk to each other, why should you assume that these people talk to each other? So you naturally end up with a zoo of technology, with a zoo of different types of coding, with a zoo of different types of approaches and so on. And this is something. This is a challenge in large microservices projects. So let's look back at the benefits that are perceived. You have agility. You have faster time to market. That's true. But often the minimal viable product is perceived as, hey, it works, cool, let's put all our customers on it. Yeah, no. Let's talk about the performance again and the scalability and so on. This is something, a challenge, and this is something you need to discuss with your clients. Promise of more innovation. I've already talked about it. You really must make a conscious decision which tool you're going to use, and not just because, this is my favorite language of the day, let's use it for this project. But it has to have some real benefit, and it should have this benefit at least midterm. Earlier days I would have said long term, but with microservice we can just replace it much easier nowadays. But still. Promise of better resilience. We have great tooling now. Service mesh and all that stuff, auto-scaling, circuit breakers. You could build that all in your classic application, in your monolith as well, and I've done that. This all works, but it all adds complexity. Scalability, the same thing. You can scale your application much easier, and you can scale only those parts that need scaling as they need it, but in total may use more resources. You have more runtimes running at the same time. You have a lot of sidecars that need more memory and so on, and compute power. You have more context switches. You have larger latency and so on. It's all you really have to consider that. Promise of better reusability. If you do modularization, you could do that in a monolith as well. You can reuse stuff much better, but the coordination effort and the management of that is often difficult because of those communications problems I mentioned. And then you end up forking stuff, and then you have double maintenance maintenance efforts. So the improved return on investment, yeah, in the short term, it works, but productization effort to really make it work in a large scale system. Once you've made a decision to go from minimal viable product to a production environment with all your non-functional requirements, security, scalability, really scale it up, this is often underestimated. So in summary, microservice is a cool thing. I've been hated for because I implemented in Eclipse tons of projects with different dependencies, which actually implemented some kind of self-contained systems with microservices and everything just in Eclipse. And I couldn't, let me just call this because it's easy. But this application actually still lives after 18 years. So proper modularization is key, as has been said in a previous talk. Fix your structure. The deployment granularity improves the scalability, reuse. You can more easily replace stuff. But also, if you don't need microservices, you can also use a monolith and use containerization, auto-scaling, resilience features of your service mesh there as well. And standardization improves efficiency. If you have 15 teams and everyone has to reinvent the wheel, you're losing a lot of your efficiency. Yeah, communication is key. Conway's law will hit you. You have to get your communications right. You have to get the people talking to each other, at least some coordination working, and they have to be aware of that. Okay, then that's the URL for my article, where you find it in all epic lengths. And thank you.
Thank you very much.
Are there any questions?
Over there's a question. Okay, thank you for the talk. Just a comment on what you just said. I think it's really helpful for every one of us. Standardization is helpful, not just in a bunch of teams, but I think worldwide. Don't you think that microservice or standardizing microservice is a way of standardizing the whole implementation of application, and even the migration to monolith is actually a way of trying to find a standardization technique, applying microservice to migration to monolith?
I don't think you can apply standardization, at a global scale. I mean, you have some technical standards. I mean, everyone uses JSON and web tokens and so on, and that's fine. But I think, from my experience, most of the projects are still different enough. So I don't think you can apply some kind of standardization globally. But in your project, if you have a large project which has multiple teams, there you can actually apply some kind of standardization, because also then your requirements are hopefully homogeneous enough, or you can at least categorize your services. Like, you have some services that the set is homogeneous in itself, and it says, okay, you can use this implementation approach, and this, like synchronous calls from your web, and the other one is a streaming application. You use another. So you have two different standards, but you have at least some standardization and reuse possible.
Thank you very much. Any other questions? This one.
No problem.
Okay, so I'm just curious, when you come into to a new customer and they want to apply microservices and so on, how do you actually educate the team to be so, to take all the metrics, things you put on the slides into account? Or it feels like they should visit the university again and I don't know, hear one or two lectures and then they can start working on it. Or should we just put faith into them, just like Eberhard stated?
Faith into
Faith into the development team and just give them the responsibility.
No,
they will somehow magically do it.
I mean, that's indeed a good question, and this goes into it. It goes into the topic of how do you do a good job as an architect, and there are many things. My approach is I try to be a servant leader. Yeah, I try to take the obstacles out of the way of the development team. But in such cases, I ask questions. I look what they think about it. Maybe that's for me a way to learn also. So maybe they know something that I don't. Sometimes it happens. And then we find a common solution. Yeah. It helps to have some street credibility, so I'm still hacking my way through the code. But yeah, that's how I do it. Yeah.
Wonderful. Thank you again for this lovely talk. Thanks.
You're welcome.